Alright, welcome to the first video of Vonometry for Calculus AB, Graphical Approach to Limits. So you should probably look over this or pay some attention to this because it'll link up to some future units, but it's pretty simple. So for the first thing over here, just look at it this way. Like the first one is this one, limit f of x as x approaches 0 from the positive side. So basically what it means when it's approaching from the positive side is that it's going from the right to whatever value you have. So here, it's saying that we're approaching x equals 0. So here, it means that we're getting towards the x that is 0. So you can just draw a line right in between, right here. You can see, oh, 0. And there's two lines that intersect or go towards that value. So on the positive one, we see that as we go from the right side towards 0, we are going to hit 5 on the y. So that's going to give you your value for the first one, 5. So basically, for limits, you're going from an x value, or you're going towards an x value from either the left side or the right side. And then whatever y value you get from that is what it's going to be your answer. Now on the other hand, if it's a limit as x approaches whatever number, in this case 0, from the left side or negative value, and just go up, follow the line, and go up. Here we can see that it's 1, 2, 3, so it's 3. The y is 3. So that's our answer for limit f of x, x approaching 0 from the left side. Now on the other hand, limit f of x as x approaches 0, and it just means that both the lines, or from the left side and the right side, they're going to intersect. It doesn't really matter if one is a hole and one is a solid point, as long as they actually join together, then it'll actually give you a value. For example, here they don't join together. You have a spot right in between here where they don't cross. That means that the answer for this is going to be undefined or DNE. That's normally what you're going to put in the case that you don't have a value, DNE. On the other hand, you have f of 0. This case, whether the value is a hole or an actual point does matter, since a hole is not an actual value. It just means that it does go there, but it doesn't really exist there. So if we go from here, we can see that you have these two. You have a hole, and then you have the actual one, an actual hole, an actual point over here. And when we follow it, like over here on this one, we get a value of 5. So we just put 5 over here, and that's going to give you your value. F of 0 equals 5. Now for the next one, we have this. You're just going to do the same thing basically. You're going from the positive side towards 3. 3 being over here, right over here. And we can go follow this side, boom, all the way up, bam. And then we can see that the y for this will follow around 5. So it's going to be our answer for this one. On the other hand, when we're looking for the limit f of x, x approaching 3 from the negative side, which just means that it's from the left side towards the x value, we're going to follow this one and go all the way until we're here. And we can see that that's over in 3. The x equals 3. We just look at the value and we see it's 1, 2, 3. 3. So the answer is going to be negative 3 because it's in the negative side under the x-axis. And now we can see the next one, limit f of x as x approaches 3. Again, just like the other one, this one doesn't connect. We have a hole over here and another hole over here. And they don't, which wouldn't be an issue for this one, but they would have to join together, which we will see in the next question. But this will give you another DNE for your answer. On the other hand, you have f of 3. This one you actually do have value since you have this answer right here. You have 1 point. Despite it not like joining up with the graph itself or like the two lines, that doesn't matter because it just wants a number that actually exists there. And at x equals 3, you have 0 because the y is going to be 0 at that point. So that's going to be your answer for that. Now we have this one. We have limit f of x as x approaches -1. So we go to -1, x equals -1, which is going to be right over here. And we go from the right side, because it's positive. We just follow it along, down, all the way until -1. And right here. It's going to be 1, 2. Right there. So it just means that your answer is going to be 2. And then you have the next one, which would be limit f of x as x approaches -1 from the negative side, or from the left side. So you follow down from the left side all the way down towards the -1, and you reach the same thing. You have 1, 2, y equals 2 again. So this limit's going to be 2. And in this case, just like unlike the other ones, this one does join up together. You see that it doesn't have any breaks in between the two lines. It actually joins together right here, which is going to give you a value of 2 and not DNE. Then you have f equals -1, because it's f equals -1 on this one, but we have a hole that's going to give you a DNE number, or does not exist. Since it's a hole. Now we have basically the same thing over here. We're going to do the same thing. So we follow along from we go for the limit of f of x as x approaches 0 from the positive side. So right there, all the way until 0, and we get another 2. So boom. Then we go from the left side towards 0, and that's going to give you another 2. Because that's, because that's where your y is. So that's another 2. And now we have limit f of x as x approaches 0. Here it does join up together. So that means your answer is again 2. In this case, well, for that limit, as x approaches 0, it doesn't matter if the point's over here. You just don't look at it. Think of it as doesn't exist right now. It only really matters for this case until you get to this, the f of 0. Because it won't count with a hole, but we have an actual value or a point over here, which is at y equals 5 for the x equals 0. If it was anywhere else, like if it was at x equals 5, then it just doesn't matter and it will be a DNE again. But the answer for this one is 5. Okay. Now for this one, it's again just the same thing as the other one, but instead of having a hole or a point outside of the actual line, it will be inside. So for limit f of x as x approaches 3 from the positive side, or from the right side, you go down to 3, x equals 3 over here, and you see that the y value is going to be 4. So the answer is 4. Now we go for the limit of f of x as x approaches 3 from the negative side. You go down, 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 down until 3 from the left side. And you see that again, it's just 3 on the y. So, wait, no, 4. Oh, my bad. And then limit f of x as x approaches 3. They join up together, so that your answer is going to be 4. Same thing as the last one. And f of 3 here, 3 is right here, and we have a point right here. So our answer is going to be 4 again. This isn't too hard, it's just you have to follow along with if it's going left or right and just looking at the y values. Now for another one, it would be this one. This is going to be a little bit weirder, but not really. It's pretty simple. So we're going to look for the limit of f of x as x approaches 2 from the positive side, or the right side. So this is the graph from the right side. So we're going to follow this one all the way up, and bum. So we see that's going up, but we don't have an actual value. But what you can see is that's going infinitely up, or it's increasing infinitely up in the y axis or y direction, or whatever. So your answer is going to be positive infinity. But another thing for that is that in this case, when you solve these questions, positive infinity can also be substituted for DNE or non-existence because infinity doesn't exist. So you can also just put DNE for your answer for this question. Now we do limit f of x as x approaches 2 from the negative side. So we go for this one, this graph, and we follow it from the left all the way up, following it, and it goes up again. But it doesn't actually have a solid number or a value that intersects at 2 over here. So we're going to have a positive infinity again, or DNE. Limit f of x as x approaches 2. Well, here we don't have any solid values in between the line, or the asymptote. Which asymptote, it just means that your line, or the lines you have, are going to get infinitely close to that x value that you have, but they'll never actually reach it. And we don't have an actual value at x equals 2, or like a solid point like this. We don't have any of that. So it's going to be another DNE. Then we have f of 2. F of 2 again, we don't have an actual value in between here. And this one didn't join up together. And this one doesn't have an actual value, so another DNE. Now this is the same thing, it just actually has a value at the x equals 2. So we follow along from the limit f of x as x approaches 2 from the positive side. Same thing, up, positive infinity, or DNE. Then you have limit f of x as x approaches 2 from the negative side. You follow the graph up again, and you get positive infinity because it's going infinitely up, which is DNE again, if you want to write it that way, since it's going to be simpler. Since you can get both those answers as your test problems or test answers, and you have limit f of x approaching 2. Well, you can see that there's an asymptote right in between here, and these two lines are never going to touch together, which means that you don't have a x approaching 2 value, which is another DNE. Now here's where it changes from the last question. You have f of 2. What do you have a value for x equals 2? And in this case we do, since you have it right here, you have a point despite it not connecting with the graph. And that's at y equals 0. So your answer is going to be 0. Now, this is a different type of question, or it's slightly different, but it's basically the same thing. Instead of actually looking at the x's as it approaches an actual value, you're going to look at infinity, positive and negative infinity. Unlike the other questions that we just did, you're not going to go towards from the left to the right, and from the right to the left towards the value. In this case, what you're going to do is look at the negative infinity, or limit f of x as x approaches negative infinity. We're going to go from whatever value, or whatever, let's just go from the middle of the graph, and we're going to go towards the negative side of x values. So right over here on this side. You're going to the left. And then once you have that value, you're going to go, oh, well, what value do we have for y? And we can see that as we go towards this left side, we're going to go up, infinitely up. We're going up increasingly, but without a stop. So that's going to give you a positive infinity as your answer, which can also be put as D and E. On the other hand, if we go towards positive infinity for your limits, that means that we're going from the middle of the graph, or whatever value you want to start from, towards the right side of the x values. Now that we have that, we're going to go up or down depending on the graph that you're given, and we see that this one, well, it goes up. So we draw a line up. You can see that it doesn't stop anywhere, and it goes up infinitely. So it's going to be positive infinity again, which can also be put as your answer as D and E. Now the next question. So here we're doing another infinity or limit with infinities. We're gonna go look for the limit of f(x) as x approaches negative infinity. So we're gonna go here. We're going towards the left side, or negative infinity, because this is gonna be negative infinity over here, and this is gonna be positive infinity. So we go there, and we see that, oh, well, the graph is going down this time. So we go down with it, and it never stops since you have the arrow over here, which means your answer is going to be negative infinity, or D and E. Now, on the other hand, we have the limit of f(x) as x approaches positive infinity. So we go from like the center over here, and then we go all the way towards the right of the positive infinity. And this time, instead of going down, we can see that it's going up. So our answer is going to be positive infinity because it never stops and it's going up infinitely. So answer is positive infinity, or D and E. Now this is a different type of question in the case that you actually have an asymptote, what will fundamentally change from the previous questions is that you actually have a stop, or you're approaching a stop. So we can see that limit of f(x) as x approaches negative infinity, that is going to be going towards the left side. So over here. But what we can see is that as you go down, it hits like a wall right at 5. Y equals negative 5. So your answer is going to be negative 5 for this question. Because as you go towards the left side, or negative infinity, you just can't go any lower because you have the asymptote over here. And we can see that that asymptote is going to be at y equals negative 5. So that's going to be your answer. On the other hand, for limit f of x as x approaches positive infinity, we're going to go towards positive infinity over here. And we're going to go up afterwards since the graph is going up. So we go up, boom, another wall at y equals 5. I'm not very good at drawing these graphs, but that's about it. So this one's going to be positive 5. Since it can't go any further up, and it's just blocked over here. Now, the final one is this one. This one's a little bit weird, but it's also pretty simple. The only difference is that for this one, you don't have like a really solid answer. You're more like seeing that it's closing in. Like here, limit f of x as x approaches negative infinity. We're gonna go towards negative infinity over here. Boom, this side. And as we go down, we can see that it's oscillating. It's going up, down, up, down, up, down. But what you can see is that it's slowly getting those bumps are slowly getting smaller and smaller, and they're closing in on y equals negative 5. In this case, what your answer is going to be is negative 5. you're just looking for the graph to go closer and closer and closer together. Like in another case, this would give you D and E if it wasn't getting any closer. So like this, it's just staying the same. It's not closing in or getting, yeah, just it's not getting smaller and smaller. On the other hand, we have limit of f of x as x approaches positive infinity. So positive infinity is over here. We go towards that side, and then we go up. What we can see, instead of the pattern of it getting smaller and smaller and smaller, is that we're going up constantly. We're going up, bump, up, bump, up, bump, and up. And you're just repeating that over and over again until you're going up infinitely. So that's going to give you positive infinity. Since it's repeating that pattern infinitely, and it's going up constantly. So that's going to be your final answer for that. Well, thank you for watching the first video of Vonometry, and have a good day.